Hi, everyone. Thank you for joining us for our next live stream. I'll be your producer for this session. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speakers for today. Thank you for joining.
All right. Hi, everyone. Thanks so much for joining us on another Monday for our 4th episode of Season 4 of Model Mondays, the last episode in August. And today, I'm really excited because we have folks from one very special part of our org. We're going to talk about how you can go from research to reality and put the spotlight today on Foundry Labs. If you haven't played with Foundry Labs and some of the models, you don't want to miss this. But before we talk to Gulsimo and Yash, as usual, we're going to kick this off with one of my favorite people, Sharmi. I can't believe we're 1 year down. Sharmi, tell us, so what have we got to catch up with from the past week in news? What's been exciting?
Yeah, thanks, Nitya. And I cannot believe we are 1 year down either. It's time flies. But as usual, we have a lot of interesting news happening, not just in the model world, but even in the ecosystem surrounding it. And that's what we try to put together for the highlights, not just models, but also what's happening around it so that people can build that complete AI agent or platform that they are planning to build. And we see that people are joining. So let's just get started with the first highlight. If you can move on to the next slide, Nitya.
Yeah, we're seeing Cohere.
Yep. So our first news is what happened last week. We landed Cohere Parse 5. It's now available in Microsoft Foundry, and we've been partnering with Cohere for almost 3-4 years now. And we've landed a lot of their models like Embed, Re-Rank, and the command models. Now they're bringing in Parse v5, which is a high-performing document understanding model, and it is mainly targeted for enterprise AI workflows. And what Cohere claims is that it goes beyond just traditional OCR. Parse actually understands tables, forms, diagrams, images, and document structure, so they can convert complex documents into structured markdown or content blocks with spatial information. And they also think of Cohere Parse as being used in combination with Embed and Re-Rank, because then it creates cleaner, richer input for RAG agents, search, and document automation. So their value prop is that bring it all together, and then you have the best RAG pipeline setup, which does everything. That's on Cohere. Moving on to the next highlight, Grok. We've been a little quiet on the Foundry side with Grok for a while, but of course, Grok 4.6 has been available for a few weeks now on XAI's or SpaceX platform, but now it's available in Microsoft Foundry, and it brings a new generation of workloads where it is not just about answering prompts, but it's also about reasoning and completing complex work over extended workflows. So they are thinking like I think when XAI put together this model, they were thinking of software engineering, deep research, repository level analysis, and debugging. And also they were focusing on multi-step agentic tasks where the models need to maintain the context and adapt as the work unfolds. So that's now available in Microsoft Foundry today. Go and try it out. Moving on to the next one just changing direction slightly, evaluations. Evaluations has become a hero right now in the LLM life cycle. And of course, everyone knows that a model, like I've been talking about Grok and Cohere, and all of these labs claim that they are great on a benchmark. But a model that looks great on a benchmark can still fail on cases that matter for you in your production. So on GitHub, they put together a very interesting practical lessons kind of guidance or framework for evaluating LLMs for real world secret scanning, including product specific success metrics, production representative data sets, etc. So they're treating evaluation like integration testing, and performing error analysis and using LLM as a judge to focus on the human review. And the team, they're sharing some real world examples, and the team said that they ultimately achieved a 95% reduction in false positives on its evaluated offline data set while keeping the recall within the guardrail, which is really great. And it's good to kind of go through and read that evaluation lesson so that you can implement it in your production scenarios. Moving on, I wanted to talk about retrieval pattern benchmarking. Again, focusing a lot on evaluations and benchmarking because that's becoming a very important part of that life cycle. So when you ground agents, latency alone doesn't tell you the whole story. This deep dive benchmark 5 retrieval patterns spanning Copilot Studio, Microsoft Foundry, and Azure AI Search shows how to evaluate architectures across quality, latency, cost, security, and measurement boundaries without making apples to orange comparison. So the comparison is equal. The result is less about declaring one universal winner and more about creating a repeatable, evidence-based framework for choosing the right retrieval architecture for your scenario. And finally, moving on, again, this is a little bit on the Azure Cosmos database side, but then it's important because connecting to the right data is also very crucial. And it looks like Azure Cosmos DB is evolving for that agentic era with new GitHub Copilot tools, database-specific agent skills, optional MCP support, and local development, and also integration with Visual Studio. Extension to Visual Studio. So agents can now work with real schema and query context, while developers can retain visibility and control over consequential actions. So a useful way to think about is you give tools, give agents hands, skills give them the database expertise. So check out more on Azure Cosmos DB in this in this blog. That's it. So that brings us to an end of weekly highlights. So we are moving from models that answer to systems that understand, reason, retrieve, evaluate, and act. And that's why we are focusing a lot more on that complete model ecosystem as well.
Yeah, and I'm really, really happy you set it up so nicely, because we went from models to benchmarks to integrations. And I think one of the things we have to say is that you should definitely go check out some of the kind of talks from Build as well on end-to-end optimization. Every single one of these is a lever you could pull to actually make your agentic systems more efficient. So I'm really, really looking forward to getting more of these kinds of conversations. I especially was very happy to see the GitHub best practices blog, because I think kind of having a little bit more information about how real world analysis, that really helps us kind of also, set our own expectations. But thanks so much, Charmy. I know we're getting a ton more models coming again next week, so I can't wait to see what you bring us next. Oh, but wait, next Monday is a holiday, so the week after. But we should still see if we can still kind of release a little bit of information for folks who follow Model Mondays on Discord. Thanks again. All right, so that was our news highlights for the week. But now it's time to put our kind of spotlight on the topic today. We are talking about going from research to reality. And I'm not sure how many of you have actually played with or know about Foundry Labs. That was one of my big kind of like discoveries when I first started exploring Foundry. It's not just about models, but about a whole bunch of research tools and systems and kind of papers and understanding on experimental things that you can try right now today. So I want to introduce Gulsimo Osimi from Microsoft. Gulsimo?
Thank you for having us today, Nitya.
Hi, so thank you so very much for coming to Model Mondays. I've been waiting for you guys for so long. I was wondering if we could start by kind of having you introduce yourself. Tell us a little bit about what you do and the organization you're in.
Absolutely. So my name is Gulsimo, and I'm Technical Program Manager in Core AI, so Microsoft. And I work with bringing innovations from across Microsoft, specifically models from across Microsoft, Microsoft Research, Microsoft AI, Microsoft Planetary Computer, and all other teams from Microsoft into Microsoft Foundry. And moving beyond that, I also work on bringing innovations, not just model, it can be tools, agents, frameworks to Microsoft Foundry, and giving hands-on experience to our users on Microsoft Foundry Labs.
So I think you actually had put together a bunch of demos for us, and I'm wondering if we should just dive in and look at them. But for all of you watching, as you watch, please do drop your questions in the chat, because we'll kind of bring them into the studio at the end of this segment. So if you are kind of curious about any of the models or tools or technologies you see, just leave us a question and we'll get to you. So Gulsimo, should we roll tape?
Yes, let's dive deep into the demos.
Awesome.
Let's start with a quick video. The idea of bridging the gap between Microsoft's frontier AI research and the people who want to build with it is really at the heart of Foundry Labs. So the experience is designed around three key pillars: discover the innovation, experiment with it, and shape it. AI innovation is happening everywhere across Microsoft. You might find a new research paper that was published by Microsoft Research, a new model from Microsoft AI, an experiment from another Microsoft team. You might look into the paper that was published in one place, and then the code might live in another place, and the model itself or the demo might show up in completely different place. So the challenge becomes to keep up with all the innovations that are scattered across all the different surfaces that you need to be aware of. So before you can even start experimenting, you need to spend hours just trying to piece the story together. That's where Foundry Labs comes in. It brings these innovations together in one place so you can quickly understand what's new, why it matters, and most importantly, what can you actually do with it. But discovery is just the first step. Because let's be honest, developers don't just want to read about the exciting innovation. They also want to get their hands on it. So Foundry Labs is not just a gallery where you look at an interesting research and move on. Whenever possible, innovations come with something that you can actually work with, whether it's an interactive playground, an open source repository, model access, technical documentation, or another way of starting the experiment. So instead of going from that's interesting, you can go straight to let me try it. And hopefully you end up with building something with it. And that's the real goal, shrinking the distance between breakthrough and something you can put to work. Lastly, a lot of these technologies are still evolving, which means the people using them aren't just consumers of the technology. They're part of the feedback loop. Through research, GitHub repositories, community stories, and events, Foundry Labs gives opportunity to developers to connect with technology and share what they're learning and engage with the people building it. Now, if you're curious what AI actually looks like across different fields, then this is a place for you to wonder. So, Foundry Labs features innovation across 6 domains, so you can explore by curiosity instead of just keywords. So, if you are someone who is fascinated by planetary scale problems, then you can explore models tracking weather patterns, mapping climate shifts, and reading satellite imagery at a global scale. And if you want to see AI step into physical world, then robotics and physical AI shows machines learning to understand objects, navigate space, and take physical action. If you're wondering what AI can do in biomedicine, you'll find models decoding proteins, analyzing pathology, and accelerating drug discovery. Want to see AI changing software? Then you can explore models and tools that write code, debug systems, and coordinate teams of AI agents. Interested in driving creative tools, then dive into tools and models that generate images, speeches, and the entire 3D worlds. And lastly, if you're curious about material science, discover models simulating and even designing materials that don't exist yet. So as you can see, no matter where your interest lies, there's definitely a project for you that you can explore and look into. So now let's explore the innovations page. The full innovation catalog contains more than 55 experiments and production capabilities in one place. So I know this can be a lot to take at first glance, but with few clicks using the filters, the entire portfolio turns into a focused shortlist. So let's look through the filters. So here are the domains that we just looked through. Let's select one of them. Let's say we want to look into creative and generative media. Then we also have a status filter that basically lets you know whether the project is experimental or if it's production ready and you can use it in your production workflow. Let's choose experimental for now. So then you can also filter innovations by the type, whether you're interested in exploring agent system, applications, benchmark and environments, framework and SDK, or you want to find a model, then you can choose it accordingly. Lastly, you have the capability filter that lets you uh, choose which capability of the model you are looking at. So you can select there as well. So here we have a short list of 7 innovations that match the filters that we've selected. So now let's select one of them, let's say Trellis, and let's go into the innovation page for it. Here is a question Trellis asks you to imagine. What if a single image could become a complete 3D asset? So Trellis takes a 2D image or a text prompt and generates a 3D object fully textured out of it. So in this page for Trellis, you can play with the interactive playground for it, and you can also explore a brief section on what this innovation is about, what are the key capabilities, and what is the technology stack for this innovation. Once you're ready to explore it further and you are either interested in reading a blog about it or diving deeper into the research paper or exploring the GitHub repository for the innovation, you can navigate to those through the Foundry Labs page. Lastly, and most importantly, once you found the model or the innovation that you would like to use in your project, then you can go ahead and explore it on Microsoft Foundry. So now let's navigate to Microsoft Foundry to see the flow there. So how can you find the Foundry Labs innovation on Microsoft Foundry? So the answer to that is simple. You need to navigate to the collections and look into the Foundry Labs collection. So here you can see all the innovation, Foundry Labs innovation in this collection. And you can navigate to select model, let's say MAI Voice 1. You have the model card where you can read all the details regarding use cases. You can also find pricing and technical specs, along with responsible AI and license details. And you can navigate to either Playground, or you can also feel free to deploy a model in your project and then use the endpoint as part of your project as well. Now let's go back to the Foundry Labs website. So while we are on the innovations page, let me give you a sneak peek of 3 other innovations that we've launched on Foundry Labs very recently. Starting with FMFB Grounding model. So this is a vision language detection model that identifies 6 categories of land and maritime objects across satellite, drone, and ground imagery. Next is Aurora. It's a Microsoft Open Foundation model for Earth system that now incorporates 22 additional weather variables alongside hourly and ensemble forecasting that can help us sharpen the accuracy of weather and climate prediction. And lastly, PASA. This is a Microsoft Research Africa initiative, and its purpose is to advance speech recognition for low resource languages. This includes the first automatic speech recognition benchmark that spans across 52 models and 39 African languages, alongside data efficient models and community developed implementation guide. So these 3 very different problems, geospatial detection, language accessibility, and planetary scale forecasting, are just a few of many that you will be able to find on Foundry Labs. So now let's go to the story page. So the story section adds another important perspective. So the Innovation Catalog tells us what the technology can do, but the story shows us how the builders across different organizations are turning these capabilities into business outcomes. So Zupol, EY, and SLS, a few companies to name that you can find the stories for on this page. So this page helps us learn from how organizations are using the innovation and come up with the creative ways of how we can use those innovations in our projects. Lastly, I would like to navigate through the community page, which is also one of the very important pages. So the community page extends that connection that I mentioned in the beginning. Foundry Labs connects more than 25,000 developers through events, publication, Microsoft Tech Community, and Discord and Reddit channels. So this is the community that helps improve and provide feedback to us, while developers can also benefit from it by getting access to the technical discussions, samples, and experience of other builders. And this together completes the Foundry Labs cycle. So we discover an innovation, we explore and build with it, and lastly, we connect with the people that are shaping what comes next. So let's return to the homepage. So in last few minutes, we started with a broad view of Microsoft AI innovation. What we cover today is a fraction of what's on Foundry Labs right now. 6 domains and more than 55 innovations, all live and accessible to you. So I would highly encourage you to go further on your own. Pick a domain of your interest that either connects to your work or disconnects to the area of your curiosity. Open an innovation and see what you can build with it. Thank you so much for your time, and we look forward to your feedbacks. Nietzsche, I think you're muted. We can't hear you.
Of course I was. No, I was just saying that I really, really love the Foundry Labs refresh because of all the kind of filters that let us see these. Like, there was a huge collection of models and papers, but we were never able to kind of navigate them easily. And I really, really love this. So I had one question. And meanwhile, if people have questions on the chat, just put them in and we can track them here. I had one question for you. Like, given there's a long weekend coming up soon, if people had to start with one model here, what would you encourage them to start with if they wanted to start exploring labs? Is there one particular place that somebody who's absolutely new to Foundry Labs should start?
Oh, that's an interesting one. So we do have the featured section in the homepage. So you can scroll down there, and we usually have 5 technologies that we are featuring. So I would recommend starting there.
And the other thing I was going to say is, I know a lot of you kind of publish papers and all, and I put this in the chat. One of the good places, and you can let me know if this is a good resource as well, is the Hugging Face Microsoft organization. I think you publish a lot of things on there, so you should definitely follow the researchers there, follow the organization, and get early access to it. Any final thoughts you have for developers looking at Foundry Labs before we switch to FARA 1.5?
Absolutely. I think right now the innovation space is moving so fast that it's really important to get hands-on and basically get your hands on these latest research projects that are coming in and give feedback, connect to the community that also shapes it with you. And I think that's how we can move forward. That's how we can build together.
Yeah, and don't forget that you can find all the Foundry Labs pages on labs.ai.azure.com, and you can try them out as she showed you directly in Foundry. So the first step is to just deploy one of those models, play with it, and then leave us questions. Let us know what you think. We'd love to bring back more of these folks to show you some of the newer technologies. But this is a good transition. FARA 1.5 was not one of the models you showcased when you went through, but it does also come out of Foundry Labs, right?
Yes, it is featured. All the FARA model family is also featured on Foundry Labs. And I think this would be a great time for us to bring Yash to actually deep dive into it.
Excellent. So that's a great segue because I want to welcome Yash, Lara, to our show. Yash is a principal program manager at Microsoft. And if you've ever attended any of the research forum, you will find him front and center doing talks. So I'm super glad to have him here because he's got a lot of exposure, not just to the product side, but to the research community as well. Welcome, Yash.
Yeah, thanks for having me, Nitya. Hi, everyone. I'm Yash. I'm Principal PM at Microsoft, and I'm the PM for the FARA family of Cohere models. Cohere stands for Computer Use Agent, and also the PM for the Phi family of models, which is our reasoning models from Microsoft. I actually have a great demo on FARA 1.5. And in that demo, I also talk about what Cohere agents are, why are they so important, and what FARA 1.5 is all about. So shall we dive into that demo, Nitya?
Let's go do it. And then please leave your questions in the chat, and we'll come back with questions for Gulsimo and Yash at the end.
Hi, I'm Yash Lara, Principal PM at Microsoft. Today, I'm going to talk about FARA 1.5, our family of computer use agent models for the browser that come in 3 sizes: 4 billion, 9 billion, and 27 billion parameters. All of them are open weight and MIT licensed, available on Hugging Face and Microsoft Foundry. Before I talk about our models, I want to talk about what computer use agents are and why are they a hard problem to solve. A computer use agent is a model that looks at a screenshot of a browser and emits one action, such as clicking, typing, scrolling, or running a search. That's the whole interface. There is no API per website, no DOM contract, and no integration work. The agent uses the same interface that a person uses, and that's the whole appeal about computer use agents. That's why they generalize so well across the entire long tail of the web. That's also why they're a hard problem to solve. Computer use agents can solve tasks such as comparing products across 3 different sites, filling out an application, or booking appointments for you. One last thing, a good computer use agent also asks when information is missing, or the request is ambiguous, or the next click cannot be done. A computer use agent should stop and check with the user instead of guessing. Now, let's look at the loop underneath all of this. Mechanically, it's a loop with 3 beats: observe, think, act. In Observe, the model receives the conversation so far, plus the last few screenshots of the browser. Visual context is deliberately bounded, and that's a limit we'll discuss later. In the thinking part, it writes out its reasoning before committing to anything, which also makes the trace readable to whoever is watching. In the act part, the model takes one action per step, and the action space itself is much wider than just a mouse and keyboard. Actions such as memorizing a fact or pausing and asking the user for permission are also actions that the model can take. Altogether, these let the agent stay coherent over hundreds of steps rather than drifting. Here's how I think about difficulty. In this slide, left to right is horizon. If you focus on the top left, reading a single page, grounding description to a pixel, is largely handled by good vision language models already today. On the top right, holding a plan across dozens of steps with partial information and no undo button is much harder because every error compounds into the next one. But what I really want you to focus here is the axis that goes from top to bottom. If you focus on the bottom left, the public web is where you can search, compare, and extract, and you can practice on live sites all day long. But behind the login page, you cannot. If the task is to send an email or book a flight, there's no safe way to generate that experience or that data at scale because you'd be taking irreversible action in someone else's account. So if you focus on the bottom right, where it says behind the login, that is the most difficult problem to solve. But that's also what adds the most value to the user. We're going to dive into this deeper. With that knowledge of computer use agents, let me talk about the FARA 1.5 family of models. Last November, we shipped FARA 7B, our very first computer use model. It has 7 billion parameters, pixels in, single actions out, and it's small enough to run on your own machine. What made it work was not just the architecture, but it was the synthetic data generation pipeline called FARA Gen, which generated verified task trajectories from live public websites. The pipeline was the real gem here. FARA 7B also told us what was clearly missing. While it scored 34 on online mind to web, which is really great for a model of its size, what it could not do was things behind the login page, such as form filling or comparison shopping. That's the feedback that we got from FARA 7B, which we incorporated for FARA 1.5. With FARA 1.5, three things changed. The first is that this is a family of models and not just a single model. We have 4 billion, 9 billion, and 27 billion parameter models, all from one recipe. So you can pick your own point on the cost and quality curve. And each one is the most capable computer use model for its class size. Second is that it's built for interactions you asked for: form filling, comparison across sites, and the behavior around asking for approval and respecting preferences you've already stated. Third, and this is what I find the most interesting, that we went past gated domains. We built realistic synthetic replicas of real applications so the model can learn to actually send the email, not just search for it. Here is a lineup of the FARA 1.5 models: the 4B, 9B, and the 27B model. I want to point out that all three models are SOTA for their class size. The 9B model gets 63.4 on online mind to web, whereas the 27 billion parameter model gets 72.3 on online mind to web and 88.6 on Web Voyager. I want to also take a moment to spend time on FaraGen 1.5, our data generation pipeline that powers FARA 1.5. FaraGen 1.5 has three parts, and they're modular, so each one can improve independently. We have environments that generate tasks. Then we have strong solver that attempts them, working against a user simulator. So the model sees what a real back and forth looks like rather than just a monologue. And then we have verifiers that decides what survives. The verifiers judge three things separately. Did it reach the right answer? Was it efficient about it? And did it handle the user well? fail on any one of these three, and the trajectory never reaches training. That is a very strict filter, and it's deliberate. Now, remember the talks about login that we had discussed before, about which the data doesn't exist? Here's how we fill it. The problem again is that you can't practice gated tasks on live web, that is, tasks that live behind login page. So we build those websites ourselves. We collect real interaction traces on the domain we want to replicate, hand those to a coding agent and have it write a specification, and then a working sandbox clone. There's real front end, real API, and real database. Now, let's take a look at the results of our evals on FARA 1.5. FARA 1.5 9B scores 63.4 on online mind to web, which is double the score of FARA 7B. FARA 1.5 27B scores a whooping 72.3 on online mind to web. Both the models are the most capable computer use agent models for their class size. And now, a very important part, safety. The model is trained to refuse harmful tasks on public safety data plus internal tasks written under Microsoft's responsible AI policy. Second, it's trained to stop and ask at critical points such as missing information, an ambiguous request, or an irreversible action that it hasn't been authorized to take. We recalibrated that behavior in FAR 1.5 based on real usage, so the triggers are still great as they should, but they no longer interrupt ordinary form filling. Third, when it runs inside Magentic Light, every action from FAR 1.5 is logged and auditable. The browser is sandboxed, and you can stop the agent at any time. Remember, FAR 1.5 is a research preview. Prompt injection and online scams are open problems for anything that drives a browser. Please read the model card of FAR 1.5 before you start using it. FAR 1.5 was released along with Magentic Light and Magentic Brain. Magentic Light is the agentic app that works across your browser and your local file system in a single workflow. The two small models that drive it are Magentic Brain and FAR 1.59b. Magentic Brain is a 14 billion parameter orchestrator, fine-tuned from Qwen 3, and its planner, coder, and delegator all in one. It turns a vague request into a concrete plan, writes Python when Python is the right answer, and recovers when something breaks. FAR 1.5 is a specialist it hands browser work to. The bet underneath the whole system is that agentic capability comes from tool orchestration and action, not just from raw knowledge. And that's what makes small models viable here. The harness does real work as well. It plans step by step, actively curates context rather than letting it grow unbound, and runs inside Quicksand, an open source Qemu sandbox. Now, let's look at a demo of FAR 1.59b in Magentic Light. We give Farah the task of finding a restaurant reservation and directions. Farah opens a browser on the side and searches for that information. As Farah is taking action on the browser, it's giving us its entire thinking and thought process. All the information is easily auditable and traceable. You also have the option of taking control over Farah and over the browser in Magentic Light. We can see over here that Farah is extremely good at taking actions on drop-down menus and selecting date and time, tasks which are usually otherwise very complex for computer use agents. Now, Farah is finding the directions to that restaurant. It's open Google on the side. As Farah finds this information, it stores it in its memory to give us later. Once Farah has all the information, it gives it to us. We can see that it has found us the restaurant, it has shown us reservation, and it's also given us the directions. Let's try another task. Now, we ask Farah 1.5 to compare coffee tables. Farah 1.5 opens a browser on the side in Magentic Light. As per a prompt, it first goes to the first website, then searches for coffee table. The great thing about using Farah 1.5 in Magentic Light is that its entire thinking is fully visible and auditable and traceable. You also have the ability to take over control of the browser anytime. Farah 1.5's actions are also visible live, but if you want to see the history of its actions, you can always toggle the live switch over here and see its history. As Farah finds the coffee table, it stores it in its memory to present it to us later. Now, Farah has gone to the second website to search for a coffee table as per a prompt. Now, Farah goes to the third website to search for the coffee table, just like we asked. There we go. Farah has accomplished the task, and it now presents us three coffee tables in a table.
Excellent. So I want to bring Yash back because I saw there was a bunch of questions on the chat, but also wanted to kind of send you a link to Farah 1.5. Yash, my jaw was dropping because you just solved something for me. I literally have to make a demo on. It was magnificent. First, I want to take the questions from the chat, and then I want to kind of ask you one other question before we wrap. But I think the same person had asked two things. First, Marcus Hightower, 9250, said, not sure what open weights means to a model. And I know you were you had an answer for Farah. So what do open weights mean to the Farah 1.5 models?
Yeah, open weights means that the weights, the parameters of the model are freely available. You can download them. Farah is a small language model, a small model, so you can download them on your device and run them locally as well. And Farah 1.5 is MIT licensed, so you can use it commercially. They're available on Foundry and Hugging Face. But that's what open weights means: freely visible weights, freely downloadable for anyone to use, and you can build on top of it as you want.
And I think Marcos actually had a follow-up question as well. And he was asking, what size hardware are we talking about for the smallest 4B version to be usable for a user?
Yeah, that's a really great question. So the 4B model is specifically designed to run on device. That was one of the things that was missing in the market. So now you have a frontier SOTA core model, which is 4 billion parameters only in size, that can run on device. And when I say on device, if it's unquantized, you need probably like a 16 GB GPU. And if it's quantized, then you need an 8 GB GPU. So that would mean like your laptop is good enough to run that model.
I actually have a bunch of questions where I have to come ask you after this, but I had two main things. Magentic UI. Magentic UI is yet another Microsoft Labs product, and they work very well together for CUA, but you should be able to deploy Farah 1.5 in your Foundry projects and use it headless. Any use cases that you've heard of that drive that kind of behavior? I know testing has been one, but I was just curious.
Yeah, I think so. Magentic Light has been specifically optimized for Farah 1.5. But like you said, you can use Farah 1.5 with anything. So it does not have to be Magentic Light. If you're building an application on your own, you can use it for Farah 1.5. Magentic Light is something that really helps with productivity and for automating tasks. So if, for example, you want to compare products across 3 different sites and decide which product you want to buy, you can just give that task to Magentic Light, and Farah will take care of doing all the research, comparing those products on those 3 different sites, and it'll give you the best product for you to buy. So it's really good for like automating tasks. But another really great use case for a model like Farah is accessibility for users with increased accessibility needs. And if they don't want to use the mouse or the keyboard constantly, you can just give that task to Farah, and Farah will do that task for you on the browser and give you the final output. So that's another thing. I think another use case of FARA 1.5 with Magentic Light is usability testing. If you want to make sure that your website is great in terms of usability and accessibility and stuff, just give that website to FARA to go. FARA has extremely good reasoning power, as we saw in that demo. So FARA can do all of your usability testing and accessibility testing for the website and produce a report for you.
That's actually, I think we talked about this offline. What was one thing you would love to see people go off and try? And I think you just gave them homework. So if you go do try out FARA 1.5, try one of these use cases. Website design with a built-in testing, accessibility testing, improving Lighthouse scores, etc. One last question before I let you go. There was Marcus Hightower followed up with, what size hardware are we talking about for the smallest 4 billion parameter model to be usable? Oh, no, not that one. I think there was one more. Which model would you recommend for running locally on an RTX 3080 10 gigabit VRAM? If you want to put the response in the chat or weigh in directly, either way.
Yeah, I'd recommend the 4B and the 9B model for the specific hardware. Yeah.
And Ravi says, does FARA click the I am human checkbox for you?
No, FARA does not do that. So that's one thing that I focus on in the demo as well, which is that FARA is an extremely safe model to use, and it's designed for safety and humans, and we will not let a model do that instead of a human. Yeah.
Yes, and I'll also say we need to move to the next segment. I just want to take a minute to thank Gulsima and Yash, but keep your questions coming. We do have a Discord channel where if you post these questions, we'll try to answer them there as well. And hopefully we'll get them to come back, because research models and Foundry Labs are one of the most exciting places for you to play with cutting edge ideas and tools and models. And we hope you kind of pay more attention to it. Thanks so much, Yash and Gulsima, and hopefully we'll see you back.
Yeah, thank you.
Thank you.
All right, we're not yet done because there's one more thing. There's always one more thing, but this one is a good one. One of my colleagues, Carlotta Castelluccio, works with the Foundry Toolkit team. You might have heard of Foundry Canvas. So today we want to give you a really quick peek at a short demo on how you would build with Foundry Canvas, and invite you to come to our first Foundry Fridays on Friday this week, where you can talk to the product team member, to the advocate, and ask more questions about how this works and how you can make yourselves more productive. Let me roll the demo and then leave your questions in the chat.
Hi everyone, I'm Carlotta Castelluccio from the AI advocacy team in Microsoft, and in the next few minutes we'll go from an empty folder to a hosted agent running in Foundry Agent Service without writing the scaffolding ourselves. We'll use the Microsoft Foundry Canvas, which guides you through building and deploying a hosting agent from a side panel in the GitHub Copilot app. And as we make choices in the canvas, it passes each step to Copilot with the relevant context from your Foundry project. Let's see this in action. Here's the Copilot app UI, and we have one setup step before we start. So inside the GitHub Copilot app, we need to install the Microsoft Foundry Canvas extension. To do that, we go to the Customize section, and then in the Featured section, we can see that we have the Microsoft Foundry Canvas on top as suggested canvas. The other way you can find it is you go to the Canvas tab, and either again you find it in the Featured section, or you can simply look for it by typing the name of the canvas in here. I have it already installed, but if you don't have it installed yet, just click on the tile here and you get installed in 1 second. From here, I want to create a new session with GitHub Copilot. So I'm going to click plus here to create a new session. And then I can either start from scratch, open a GitHub repository, open a local folder, or open a recent folder here that I have created to host all the files that GitHub Copilot will generate for this project. So to open Microsoft Foundry Canvas now, I just use this prompt in here. Create a Foundry hosted agent using Microsoft Foundry Canvas. For those of you who are not familiar with the hosted agent concept, it's an agent fully managed by the platform, which is Foundry in this case, in terms of runtime, orchestration, execution, so the developers can focus on its behavior more than the infrastructure. And it comes packaged in a custom container that can be executed locally and deployed as is on the cloud. as you can see, the canvas has been opened on the right side of the UI. And the canvas walks you through 3 stages. First, create a new hosted agent. So choose your Foundry project and tell Copilot what you want to build. Second, build your current hosted agent. So configuring things like model, tools, skills, and guardrails. And finally, deploy and test your agent. So let's start with agent creation. You can see here that you can have some recommendation in terms of prompt to submit to Copilot to create your first agent. So you have this Inspire Me button here. You have the Help Me Decide to kind of get a guided process with some back and forth with Copilot to create the hosted agent, or just a Hello World example to get familiar with the platform. The other thing in here is I want to double check that I'm connected to the right Microsoft Foundry project where I want to host all the resources relevant to this agent, things like model deployments, tools, skills, and so on and so forth. So if I want to switch to another project, I just open this drop-down menu in here and choose the project I need. Now, I already have a business scenario for this sample, so I'm not going to use any suggested prompt. I'm going to copy-paste a pre-built prompt in here, which is the following. Create an assistant to help a pharmaceutical company communication team, and the agent will act as a social media campaign assistant that drafts posts promoting pharmaceutical products. I'm asking to create a Foundry hosted agent for this task using Python, Microsoft Agent Framework, and the responses protocol. And I'm pointing GitHub Copilot to a specific existing Foundry project as well, which is the one I have connected in here. Now, under the hoods, Copilot is using the Microsoft Foundry skill, which is installed when you install the Microsoft Foundry Canvas in the GitHub Copilot app, and is scaffolding the agent code in my workspace. But to look at the details of what Copilot is doing behind the scenes, we want to open the folder in Visual Studio Code so we can look at the code Copilot is generating for this project. So as you can see here, Copilot scaffolded a few files already. We have a source folder with a .env example file, a Docker file configuration, a requirements file with the Python package to install to execute locally the agent. And then we have a main.py file where the core logic lives. This file builds the agent with the Microsoft Agent Framework, wiring a Foundry hosted model, which is specified in a .env file, to a set of instructions, and serving it using the OpenAI responses protocol. Now, looking at the instructions, here we are instructing the agent to act as a social media campaign assistant, and we are providing it a few rules as well as the guidance of asking for further information when unsure. Now, a .env file has been created also with the Foundry project endpoint and the deployment name, which is an existing deployment in my project of GPT-5.4 mini. And then the other thing I want to show you is the Azure.yaml file. Deployment is driven by this YAML file, which provisions the Foundry project and the model deployment, the GPT-5.4 mini model deployment. Okay, so this is the code for our hosted agent. Now let's go back to the Copilot app. So Copilot has detected I don't have a GPT-5.4 mini model yet. So it's recommending to deploy an instance, and I confirm. And once the model is deployed successfully, I can go to step 2, where I can further customize my agent. For example, now we've just created a GPT-5.4 mini instance, but I can deploy more model instances in Microsoft Foundry, and then maybe evaluate different version of the agent with different models. Then I have the possibility to add some tools and skills, but also some guardrails. Now, for these examples, I'm going to add an existing toolbox, which is these agent tools in here, including web search to retrieve timely context, such as the current season, relevant awareness days, customer needs, and so on and so forth, and a file search index to retrieve accurate product information from the supplied pharmaceutical product catalog of the company. Now, clicking on Connect, basically, Copilot under the hoods will edit my code in order to be able to access this toolbox. Let's come back to Visual Studio Code to see the results. Looking at the Azure.yaml file, I can see here that a toolbox endpoint has been added to the environment configuration. And moving to the main.py file, in the creation of the agent, in addition to the instructions, I can see that I have some tools now with my toolbox referenced in here. We are ready to test our agent. So let's click on Inspect Locally. And here Canvas runs AZD agent run, which is a command on the Azure Developer CLI to execute the agent. So it runs this command in the integrated terminal, and as you can see here that the agent is now running. And it also loads these Agent Inspector UI, where I can interact with my hosted agent. For example, let's test this prompt here. We want to run a social media campaign for next month. So create three post options promoting products that are relevant to customers at the time of the year. Now, since I haven't provided things like the market, the audience, the social channels, the agent is asking to provide some further information in order to create some more accurate social post. But what I want to highlight here is that I have an embedded UI to interact with my agent, to look at the logs, event logs in here of the text creation, for example, the response creation. And in case of tool calls, I can also inspect the logs of tool calls in here, everything in one place. Once you are happy with your test, there's the final stage, step 3, where you can deploy your hosted agent to Microsoft Foundry. So again, this button will submit a prompt to Copilot in order to deploy this agent, the code created during this session with Copilot to my Microsoft Foundry project. That's it for the demo, but I'll see you next Friday, 4th of September, with Janji Lee from the Foundry Product Group, working on dev tools like Foundry Canvas or Foundry Toolkit in Visual Studio Code to get all your doubts, questions, curiosity answered. So join the Discord and join our roundtable on Friday. See you.
Excellent. I hope you all found that to be a useful introduction to Foundry Canvas apps. This is the link to the documentation for this. But as Carlotta mentioned, go try it out. But do join us on Microsoft Discord, Foundry Discord, for a Foundry Friday AMA. You can go to that link, or you can join just aka.ms/model-mondays Discord. Note that our typical AMAs are at 1:30 Eastern time, but this one is slightly earlier because we're aligning to Junji's time zone. So definitely do bring your questions on Foundry Canvas to this chat, and we'd love to see what you've built and share your own kind of experiences with it. If you had any questions on this, leave that as well. Last but not least, we will be on hiatus next week. It's Labor Day in the US, so there will be no Model Mondays next Monday, but we will be back the week after for an episode hosted by my colleague Gustavo, where we will put the spotlight on cloud models in Microsoft Foundry. So don't forget to join us. We'll talk about tool integrations in practice, and it'll be an hour-long episode where we'll go through a whole bunch of best practices and kind of build your understanding of cloud models in Microsoft Foundry. With that, these are the 3 links you need to know. We hope you had a really good time today, and please come back, not next week, but the week after. In the meantime, join our Discord at model-monday/Discord and leave your questions and ask us a little bit more about what you think we should be focused on in this series over the next coming episodes. Thanks very much and have a wonderful week ahead.
Thank you all for joining, and thanks again to our speakers. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find our survey link on the screen or in the chat, and we'll see you at the next one.